All right. So we are going to keep going with the free response questions today. I'm also going to take a look at some resources that College Board has put out for us to kind of help us prepare for the new format. And also look at integration by parts, so kind of a review topic. So our objectives are,
Mr. Brandon,
yes.
Mr. Brandon, can I use the bathroom real quick?
Yeah,
Please.
go for it.
Thank you.
Okay, so objectives: to use relationships between derivatives and integrals to interpret the meaning of accumulated rates of change and derived rates, and then to integrate by parts. So I'm going to come back to this once Oliver's here. Really quickly, so integration by parts. You guys have this formula on your weekly formula quiz from when we were in session, which is based on product rule. So with product rule, if I had a function uv and I derive it, I'll get u prime v plus uv prime. If we rewrote this, then we could say the integration of both sides should still be equal. Because I'm adding, I can split that integral up into two separate integrals. If I wanted to solve for one part of this, so the integral of the derivative is itself, so uv. If I want to solve for one part of this, then I can move the other to the left side. So let's say if I want to solve for uv prime, the integral of uv prime would be equal to, if I subtract this integral from both sides, integration by parts formula.
I'm back.
Awesome. So all I've done is prove our formula from the quiz, so integration by parts. Okay, any questions on how we got to our formula? I'm going to give Oliver a second. Okay, any questions on integration by parts?
No.
No.
Okay, cool. So in general, we have a priority order for integration by parts, which we can remember with the acronym ILATE. Any part that you would derive will have this priority order. So if you see an inverse trigonometric function, then we should derive that. If you see a logarithmic function, that would be next, then algebra, then trig, then exponential. So this is top priority to lowest priority. So for instance, if I wanted to integrate the natural log of x in terms of x, since I can't integrate ln x directly, what we can do is I can set ln x equal to my u. That means u prime would be 1 over x, and then my v prime would be dx. So the integral of v prime would be v, which is x. And then we can substitute into our formula. So this is the integral of uv prime is equal to uv. So that's x ln x minus the integral of u prime v. So that's 1 over x times x, which is 1. And the integral of 1 in terms of x would be x, which leaves us with our integral. Any questions on what we did here?
No.
No.
Okay. We talked briefly about different integral notation last time. So this is anytime you see this crazy double d n to the function, that n, if it's positive, tells you how many times we've derived. If it's negative, tells you how many times we've integrated. So d3f would be the third derivative of f, d negative 2f would be the second integral of f.
Okay.
And if I keep going with integration by parts, last time we proved that there was a set pattern. So if you continuously integrate again and again and again and again, you end up with this pattern where every term you're deriving u one more time. So u prime, u prime prime, u prime prime prime. And every term you're integrating v prime one more time. The first integral of v prime, the second integral of v prime, the third integral of v prime, the fourth integral of v prime. Your sign also alternates. So I've got u integral of v prime minus u prime second integral of v prime plus the second derivative of u times the third integral of v prime minus the third derivative of u times the fourth integral of v prime, and that pattern is just going to continue. So what that means is, if we wanted a shortcut, then you can set up a table where you've got your u on one side and your v prime on the other. And then we can integrate. So I'm going to integrate this right side and derive this left side. So if I keep deriving, this will be x squared's derivative is 2x. 2x's derivative is 2. If I derive 2, I get 0. If I integrate sine, I get negative cosine. If I integrate negative cosine, I get negative sine. If I integrate negative sine, I get cosine. If I integrate cosine, I get sine. Okay, then following this pattern that we have up here, my original u should be multiplied by the first integral of v prime. So that's x squared times negative cosine of x. Okay, then for my next term, I'm going to subtract the first derivative of u times the second integral of v prime. So that would be 2x times negative sine x. And then add 2 by cosine x, subtract 0 times, we don't really care at this point because 0 times anything is 0, but sine x. So we're multiplying diagonally, and our signs will also change from positive to negative to positive to negative to positive to negative, which ends up giving us our result. So for our shortcut, once you know what part you want to derive and what part you want to integrate, just set them up in a table. Derive straight down for the left side, integrate straight down for the right side, and then multiply diagonally by a positive multiple, negative multiple, positive multiple, negative multiple, until you hit 0 for your derivative, and then you're done. Any questions on tabular integration or shortcut?
But we never use the first integration, or we start with the second one.
So our original problem was x squared sine x. So my first integral is actually the second line, because we started with that sign. For this first line, we have not integrated yet.
Okay.
Okay. So I've got one more. I want to integrate from 0 to infinity of 1 plus 2x times e to the negative x dx. What part of this do you think is u? And what part do you think is v prime?
The outside part. E raised to x is u.
Okay, if I try that, u is e to the negative x. What will happen when I derive?
E raised to negative x times negative 1.
Times negative 1. Okay, so I did not, I didn't simplify anything when I derived. I'm still left with that same power. Versus for my v prime and v, my v prime in this case would have to be 1 plus 2x. When I integrate that, would be x plus x squared over 2 times 2 is x squared, right? So I'm actually getting more complicated right now instead of more simple. So I need to change up my u and v prime.
Okay.
So what should u be?
1 plus 2x.
Okay, 1 plus 2x. That means u prime is what?
2.
2 dx. Okay, then v prime is e to the negative x. So what happens when I integrate?
Negative e to the x.
Okay, negative e to the negative x. When I derive, I multiply by the derivative of the power. So when I integrate, I should divide by the derivative of the power. Okay. So now we can plug into our formula. Actually, before I do that, let me talk about why we picked our u and v the way we did. If you remember our priority order for your shortcut, I-late. So we'll look for inverse trigonometric functions, then logarithms, then algebraic functions, so that's polynomials, then trug functions, then exponentials. Okay, so going down my priority list, we did not have any inverse trig functions or logarithms. We did have an algebraic function, so that's probably my u. My lowest priority is actually exponentials, and because exponentials don't cancel out when you derive them, they won't actually make the problem simpler if you make them u, which is why they're lowest priority. Trig's the second lowest priority because they don't cancel out either. If you derive sine, you get cosine. If you derive cosine, you get negative sine. If you derive negative sine, you get negative cosine. If you derive negative cosine, you get sine. So I'm stuck in an infinite loop with trigonometrics, functions, and exponentials. It's a little bit rarer to see these two as u. Okay, so then I'm going to plug into our formula. What's my integration by parts formula? The integral of u v prime should be equal to what?
One plus 2x times x raised to the negative x, e raised to the negative x.
Okay, you're right. Let's do our general formula though. So, in terms of u and v prime, what happens when I integrate?
U times v prime
So
minus u prime times.
okay, so if I integrate uv prime, I'll get uv minus the integral of u prime v. Okay, so I'm going to sub in. So this is the integral from 0 to infinity of 1 plus 2x times e to the
Okay.
negative x is equal to what?
One plus 2x times negative e raised negative x minus the integral of 2 times negative negative e raised to negative x.
Okay, awesome. So I'm going to move that negative out here. So this will become positive 2e to the negative x. The reason why I'm doing that is because I can integrate this one directly. And we've already integrated e to the negative x. That'll make this easy. I guess I'll do this in 2 steps, but so this is 1 plus 2x times negative e to the negative x plus 2 times the integral of e to the negative x dx, which we've already integrated here. So I can sub in 1 plus 2x times negative e to the negative x plus 2 times negative e to the negative x. Okay, I would normally have a plus c here, but we actually have bounds from 0 to infinity. Okay, so I'm going to plug in my bounds, infinity and 0. I think I'll factor out my e to the negative.
By why is this negative 2x, 2e raised to the x power and not plus?
So this is originally plus. So if I integrate, I'll have that sign will change to a negative, right?
Okay. Oh. Okay.
Up here for my step before that, I had a negative and a negative, which would become positive when I pulled out that negative 2.
Yeah.
The reason why I pulled out negative
Okay.
2 is because we'd already integrated the positive version of e to the negative x. Okay, so I'm going to plug in my upper bound and subtract my lower bound. So if I factor this out, this will be negative 1 over... I don't know if I can write there. Okay. Negative 1 over e to the x times
Okay.
1 plus 2x plus 2. So I factored out my negative e to the negative x from here and from here outside. Okay, is everyone okay with that first step?
Yeah.
Okay, then I can plug in my upper bound and subtract my lower bound. So I'm going to plug in my upper bound. What is negative 1 over e to the infinity power?
Zero. Negative 0.
Yep, so this is 0 times something is 0. Okay, and that's my upper bound, and I'm going to subtract my lower bound. So I'm going to subtract negative 1 over e to the 0 power. Times 1 plus 2 times 0 plus 2. Okay, so we said this one is 0 for my upper bound, minus, what is 1 over e to the 0 power?
1. Negative 1.
Yep, so this is negative, because I got that negative sign here, so this would be negative 1 times 1 plus 2 is 3. So this is negative 3, and I've got a negative on the outside, so that's negative negative 3 is positive 3. Okay, any questions on what we did here?
No.
Okay. I'm going to go back really quickly. I know I signed us up for this at the very beginning of the year, and then I ended up just printing stuff out and never actually using the online portion. But I've got a feeling that the format's going to be really similar now that everything's going to be online for our free response. So I kind of want to get used to submitting assignments through AP Classroom, because that's probably how you're going to submit your AP exam.
When did they say again that they're gonna release the date for the for the exam?
April 3rd. So later this
Okay.
week. But we won't know until then. So on the first slide of this PowerPoint, later on, if you can go to myap.collegeboard.org and sign into your College Board account. So that's the same account you use to register for your SAT and for the AP exams. You're both already in my class, so you shouldn't need the join code. But just in case, I've got that here. I've assigned 2 more problems that are similar to what we just did. And I'd like you guys to try them and submit them by the end of the week, so by Friday. Just to check and make sure that you can submit assignments through their system. Again, because I think that's how you're going to submit your AP exam.
Okay.
So this week is just a test for that. And then we'll also have our normal stuff. So for the rest of this, I've got one more free response question for us to go over, and then we'll get to the homework. So here I've got a particle that's moving along the x-axis that the velocity is given by sine of t squared. And we've got our graph of velocity and time here. The position of the particle at time t is x of t, and the position at 0 is 5. Okay, so I've heard a lot from Oliver so far, so I'm going to jump over to Junho. How can I find the acceleration at t equals 3?
UI.
Okay, I'm going to derive. So v prime t equals a of t. What's the derivative of sine t squared?
Uh, 2t cosine t squared.
Okay. So then a at 3 would be what?
6 cosine 9.
6 cosine 9.
9.
Okay. So 6 cosine 9. I believe for this year, 1, 2, and 3 were all with a calculator, so you would have a calculator for this. But you could leave it as 6 cosine 9 if you don't have a calculator. I'm going to throw up a calculator so we'll get our decimal answers, just so we can match the scoring guide later, but this is 6 cosine 9 is negative 5.467.
Mm-hmm.
Okay, perfect. Any questions on part A? Okay, part B. Let's go, Oliver. I want to find the total distance traveled from 0 to 3.
We have to integrate from 0 to 3 the sine of t squared.
Really close. So if I'm looking for total distance traveled, I'm not just doing the integral, I'm integrating what?
The absolute.
Absolute value, perfect. If you just integrate, you'll get position. If you integrate the absolute value, you'll get the total distance traveled. So this is... We're going to integrate the absolute value of vt in terms of time.
Okay.
Or... the integral from 0 to 3 of the absolute value of the sine t squared dt. Now, because this is with a calculator, it's okay to go straight from here into our answer. So this would be, I'm going to go ahead and plug this in as a function in case we need it later, but this is the sine of x squared is y1. Then math 9 is our integral. I'm going to integrate variables, y variables, function y1. So the sine of t squared in terms of t. I need the opposite value, my bad. I'm going to integrate, I believe that's here, math, numbers, ABS. So that's absolute value of variables, y variables, function y1. So the absolute value of the sine of x squared in terms of x from 0 to 3.
Where is the absolute button again?
If you go to math number, it's the first option, so ABS.
Okay. Thank you.
Okay, so this is 1.702. If we did have to do that without a calculator, then what I would need to do is figure out when this function would be equal to 0. Because that would tell me when the sign changes from positive to negative. And the sign normally changes from positive to negative at pi. So I'd have to go and say pi is equal to t squared, or t is equal to root pi. At this point, my sign will change from positive to negative. I would have to integrate from 0 to root pi of the sine of t squared dt, and then add
Oh, that's a lot of work.
-1 times the integral of root pi to the point where it becomes positive, which would be the square root of 2 pi. Of the sine t squared. I'd have to check and make sure that the square root of 2 pi is still not up to 3 yet. Pi is roughly 3.2-ish. So this is 2 times 3.2 is like 6. The square root of 6 is not quite the square root of 9 yet, which would be 3. So that means I would still have to add another integral from root 2 pi to 3 of the sine of t squared. But I took the part that was negative and multiplied that by -1 to make it positive. And if I did that, I would still get 1.702. Thankfully, this is with a calculator. We didn't have to do that by hand, but if we did, that's how we'd set it up.
Yeah.
Any questions on our setup?
No.
No.
Okay. Then Junho, we're back to you for part C. Find the position at t equals 3. Junho, we're over to you. So I'm gonna find the position at t equals 3. What do I have to do?
Integrate velocity.
Okay, I'm integrating from 0 to 3. That'll tell me how much my position changed from 0 to 3. If I integrate our velocity. And then if this is how much my position changed, what do I have to add?
5.
Right. Um, so my general form there was x at 3 equals wherever we were at 0 plus my change in x from 0 to 3. Which is what this integral actually is. Okay, so if I integrate from 0 to 3 of vt, I'm going to integrate our vt in terms of x from 0 to 3. So this is how much our position changed. And I'm going to add our original position, which at 0 was 5. So if I add 5, we get 5.774. Okay, any questions on this one?
No.
Okay, then last one. Oliver.
Yes.
So I want to know, on the interval from 0 to root 5 pi, what's the time when the particle is the furthest to the right?
Do we have to find the extrema,
Yes.
the maximum? So we integrate and find out where it is 0, and then do the second derivative, plug it in, and see if it's positive or negative.
Okay, so this will be the different times we'll have to test and our position at those times. Because we already have the derivative of position, we've got velocity. Whenever the velocity is equal to 0, we're changing direction, right?
Yes.
So I can set vt equal to 0. And solve for t. And that will tell us all of the times that could be maximums or minimums. Now, because vt is the sine of t squared, when is the sine of our angle equal to 0 on the unit circle? You're right, go for it. So at 0,
Pi
at pi.
and pi.
Okay, keep going. We need a couple more.
2 pi.
Okay. So all of these, when we're changing from 2 pi, 3 pi, 4 pi, 5 pi. Okay, I'm looking for when we are the rightmost, which means I want to know when the sign changes from a positive value to a negative value. Which ones of these, 0 pi, 2 pi, 3 pi, 4 pi, 5 pi, does sign change from positive to negative?
The 0 pi, change to positive. From positive to negative, right?
Yep, from positive to negative. At which angles?
So, pi, 2 pi, and 5 pi.
Perfect. Pi, 3 pi, and 5 pi. Since our angle is t squared, I can take the square root of both sides to get the square root of pi, the square root of 3 pi, and the square root of 5 pi. Okay, so those are our values we need to test. Root pi, root 3 pi, root 5 pi. I should also test the bounds of our interval, since we've got a start point and an end point. So 0, root pi, root 3 pi, root 5 pi, and 3. Since we're integrating, oh, never mind, we're integrating from 0 to root 5 pi. So that's actually the end bound. Okay, so I'm going to plug these values into our position function, and we'll figure out which one is the furthest to the right. So we said VT is 0 and changes from positive to negative when t is root pi, root 3 pi, root 5 pi. Okay, so I'm going to jump into my calculator, and we'll take a look at those values. So this first one, we were given the position actually, so don't need to plug anything in, but at 0 our position was 5. Okay, for all of these other ones, our position at any time will be equal to 5 plus our integral from 0 to t of the sine of t squared dt. So that's 5 plus our change in position, just like we did for Junho's question on part C. So I'm just going to plug that into our calculator, and we'll get those values. Okay, so this is 5 plus math 9, our change in position. So that's the integral of y1 in terms of x from 0 to our time. Our first time is root pi, square root of pi. Okay, so our first point is 5.895. Okay, our second point, I'm going to hit second entry, and that's going to copy paste everything I just typed. I'm just going to go back here and change this from pi to second insert 3. So it's now 3 pi, and hit enter. Okay, so same formula, we just changed what we're integrating for our upper bound. So this is lower, this is 5.788. And we're going to do the same thing for, okay, second entry, and change that 3 to a 5. So this is from 0 to the square root of 5 pi now. Gave us a position of 5.752. 5.752. Okay, so which one is the furthest to the right?
Root p.
Root pi, perfect. Okay. The particle. The particle is furthest to the right. At t equals the square root of pi. Any questions on what we did?
No.
Okay.
No.
Awesome. Well, thank you guys for coming. Again, please check out at the very start of this slide, myip.collegeboard.org. I've assigned 2 online problems just to check and see if you guys can submit using College Board system to kind of get familiar with how they're going to run the free response question, I think, this year. And then the real homework for today is the other 2 free response questions. And it's still the same for your response document as last time, but I'll post again to the chats. So this is here. We'll save our annotations too, so you can go back and check out the FRQ if you want to. All right, thank you guys very much.
Thank you.
Goodbye.